Good morning, everyone.
Good
Good
morning,
morning,
ma'am.
ma'am.
Morning, ma'am.
Good morning, ma'am.
Take some.
Good morning, ma'am.
No, I
Good
can't
morning.
hear you. 1 minute. Okay. 1 minute, guys. Yeah. Good morning. All right. I'll just take attendance. I hope you're able to see my screen. Karan. Sridhar.
Present, ma'am.
Alan.
Present, ma'am.
Subhash Ram.
Present, ma'am.
Richin. Tom.
Present, ma'am.
Present, ma'am.
Anthony. Anthony. David.
Present, ma'am.
Karen.
Present, ma'am.
Brian.
5%, ma'am.
Present, ma'am.
Hazel.
Present, ma'am.
Jacob. Evans. Praveen.
Present, ma'am.
Vishnu.
Present, ma'am.
Eddie Daniel. Prashant.
Present, ma'am. Present, ma'am.
Mukesh. Ashwin.
Present, ma'am.
Present, ma'am.
Avika.
Present, ma'am. Rohit,
Vikash.
present, ma'am.
Paul. Okay. Arun.
Present, ma'am.
Present, ma'am.
Sriram. Arun.
Present, ma'am. Present, ma'am.
Jason. Kristen Daniel.
Present, ma'am.
Bebin.
Present, ma'am.
Balakrishna.
Ma'am,
Present, ma'am.
present, ma'am.
Alex. Okay. Mohammed. Alex.
Present, ma'am.
Sam. Partha.
Present, ma'am.
Partha. Ajay. Kafrid.
Present, ma'am. 35 present, ma'am.
Jeffrey. Ash. Sushil.
Present, ma'am.
Richard.
Present, ma'am.
I'm 38%, ma'am.
Who?
Ma'am, 39%.
38.
5%, ma'am.
1 minute. I'll come back to that. Gibson.
Present, ma'am.
Mithun.
Present, ma'am.
Gibson Sam. Gibson Sam. Varateja.
Gibson, Sam. Present, ma'am.
Varateja.
Ma'am, present, ma'am. Teja.
What about Gibson Sam?
He wrote in chat box, ma'am. Gift on Sam.
Okay. Aditya and Bijil.
Present, ma'am. Yes, ma'am.
Present, ma'am.
5 is present. 1 is absent. UL1.
Present, ma'am. 5%, ma'am.
Jelly Daniel. And Kristen Daniel.
Present,
Harsh
ma'am.
Pawar. Why are you always late? So she.
Ma'am, 27%.
Kristen.
Ma'am, 15 hours subject, ma'am.
You have 40 more. Are starting to on overhanging
Ma'am, 27%.
Ma'am, we can't hear you. Your voice is breaking. We can't hear you.
Okay. Right.
It's the same. It's breaking.
Oh, it's not. Now, please.
Ma'am,
Now it's
12.
It's
visible.
probably your network, ma'am.
Yeah. What happened? 12?
Ma'am, I said present and you, it's absent.
Eben's I name
It's
of
Evans.
times. Okay. One minute, guys. Can you see my screen now? I'll just share my screen. Keep my wave off. Just stable. I just don't know if you're able to see the screen. No, not yet. So let's draw the diagram.
No, ma'am, your voice is breaking.
Oh, okay. I guess. Yeah. Guys, are you able to see my screen?
Yes, ma'am.
Yes, ma'am.
Yeah, okay. So I had given you a problem statement yesterday. We'll just do that. And yeah, we'll do that. So you guys can also draw the diagram. I think you already must be. Yeah. Problem is it? Okay, we'll do this. Yeah, please draw the diagram. All right. So this is the diagram that we have. So we need to
Ma'am, your
first.
presentation is kind of lagging.
It will come. Just wait for a minute. Okay, this is the problem that I gave you. 1 minute. I have to draw that again. Are you able to see my screen now?
Yes, ma'am.
Yeah, this is the problem I had given you. So we need to first calculate the reaction forces RA and RB. Okay, so to calculate that, we know the horizontal force is equal to 0 and vertical force is equal to 0, and moment with respect to any support. So I'm going to take MA equal to 0. So there is no horizontal force, only vertical forces are there. Please let me know if my audio and the screen share is working, okay? So you have RA plus RB equal to 2 multiplied by 6 is the uniformly distributed load plus 2. All right, so it's going to be yeah. So we have RA plus RB equal to 14. So keep it aside. Now next is MA. So MA equal to 0. Moment with respect to point A. So you have RB multiplied by 4. It's anti-clockwise, so I'm going to take it as positive. And then the rest is minus 2 multiplied by 6. This is the point load. Okay, minus 2 into 6 is the UDL and multiplied by 3. Full length of the UDL is 6. So the bit is equal to 0. Okay. So RB, if you calculate, you will get 48 8 by 4, which is 12 kilonewton. So finally, RA, if you substitute it here, you will get 2 kilonewton. So just write it down here, 2 and 12. Okay. The next step is to calculate the shear force diagram and bending moment diagram. So we will first calculate shear forces at every point. So at C, you have a point load. So you need to calculate after C and at C. So after C is 0 kilonewton, and at C you have 2 kilonewton, and it will be minus. Okay. Now, again, you've got a point load, that's a support, and at B. So at B, how are we going to calculate? You have minus 2 minus UD 2 into 2. So you've got minus 6 kilonewton. Okay. At B, it will be minus 6. The same thing in the previous step. Plus 12. Okay. So it's going to be positive 6. Okay. Now, coming to the point. Yeah, there's only one point left after A and at A. Okay, so after A, you'll have the point load 2 minus plus 12 the point load, and the UDL minus 6. Got it? Okay, so it's going to be 2 into 6. So how much is that? So 2 into 6 is 12. So it's going to be minus 2. So this is minus 2 kilonewton. At E is going to be 0 kilonewton. Okay, please write it down. Once you're done. Is it visible? You can please respond. Guys, am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. It's pretty slow today. Those of you who have done the calculation, you can draw the diagram. Done? Can I draw the diagram?
Yes, ma'am.
I'm now going to draw on the same page. Okay. So it's the same. and then you have B and C. So the points that we have is at C 0 and -2, and at B we have -6 and then 6. So 0, -2, -6, and then 6, and here we have -2. Right? So we can draw the diagram first 0 to -2, and then comes -6. Okay, so -6, and then 6 like this and like this. So this is -2, 6 kilonewton, -6 kilonewton, -2 kilonewton. Okay, negative, positive, negative. XFD diagram. Okay. So we have a point B here. So here at point B, shear force is equal to 0. Okay. So you should find out what is the length. So let's take this as X. And if you see the diagram, the point from A, let's consider the diagram from A to D. So you have the UDL here, which is 2 kilonewton meter. This is RT is equal to 2 kilonewton, and this distance is X. So you should find out. Shear force is equal to 0. So 2 minus 2 into X equal to 0. So X is equal to 1 meter. So this is nothing but 1 meter. Okay, so once you calculate that, the next step is to calculate your bending moment diagram. So for bending moment, we should calculate the points at C, B, D, and A. Okay, so I will draw a small diagram here. You have the UDL, you've got this, and this distance is O, your D is here, A, B, C, and you've got a. So at C is going to be 0 kilonewton meter. At B, if you calculate, it's a clockwise direction, so -2 multiplied by this distance is 2 meters. Okay, so into 2, and the UDL, it's again clockwise, so -2 multiplied by 1. Sorry, no. The load is 2. Okay, multiplied by 1. So this is equal to 8 minus 8 kilonewton meter. What about point D? So you've got the point D here, which is in this side it is 1. So this distance will be 3 meters. I hope you guys are following. So you have -2 into 5, and then plus RB. RB value is 12. So 12 into 3, then minus the UDL. Let's do the UDL part. The UDL is throughout the length. So 2 multiplied by 5 is the load multiplied by 2.5. Okay, so you will get D value as Can you calculate how much is the load? It's 10, 5. Can someone tell me? I think 1 kilonewton, okay, and A. Actually, it's going to be 0. If you calculate all, it's going to be kilonewton meter. Okay. Let me know once you finish writing. Can I draw the diagram in the next page?
Yes, ma'am.
So I have the load. This is A, D, B, and C. Okay. So at C it's 0. At point D you have -8. So plot it as this, -8. It's not working. Okay. And at point D you have 1 kilonewton meter. So, and there is UDL throughout the length of the beam. Okay, you have A. Why is that A not showing on the screen? Anyways, so it's going to be a parabolic curve. Okay, and at this point is known as the point of contraction. 1 minute, let me just draw this again. Okay. Negative, and this is point E. So point E is the point of contraflexion. So I'm going to name this as Y. You need to find E is the point of contraflexion. Clear? Okay. Now the next thing is, so what do you mean by point of contraflexion? At point E, if you calculate, sorry, bending moment with respect to point E is equal to 0. All right. So I will take the beam only A and then E. Okay. So you have a point load here and you've got a UDL. Point load is 2 kilonewton. This is also 2 kilonewton meter. Clear? All right. So you're calculating bending moment with respect to point E. So you have 2 multiplied by the length is y. Okay. And it is anti-clockwise, so positive. No. Negative. And this is clockwise. So 2 multiplied by y multiplied by y by 2. So you get y square minus 2y equal to 0. Y minus 2. Take y minus 2 equal to 0. Or y equal to 0. This cannot be possible. So y is equal to this and it is 2. That's how you solve an overhanging beam. Somehow this part is not same. Is it clear, guys?